We were discussing this classful addressing, and we saw that classful addressing has you can hear me, no? Right? കേൾക്കാൻ പറ്റുന്നുണ്ടോ? Can you hear me? Yeah, right. Oh. Classful addressing had fixed length prefix, and it had divided this address space into different 5 classes. Now that was impractical, due to various reasons, and they went for what is a classless addressing. We saw this things, okay, and classless addressing is something which is called as CADR, classless interdomain routing. That is what it is called. What is interdomain routing we'll explain later, but for the present just understand that there are no classes. So unlike the earlier case where A, B, C, D, E, such classes are not here. Here you divide this into the address length is still 32-bit, but you will also specify the prefix length also. Prefix length is variable. You can specify the prefix length. So that means some network with a smaller prefix length will have larger more nodes. That is what. So you will say, for instance, you will say 192.168.0.0/16. So that will be the this slash notation. Slash notation is used. So the blocks, you can divide them, the whole available address space you can divide into variable length blocks, M blocks. Now we saw last day also how you will get the starting address and the ending address. Starting address and ending address. So number of addresses in any block is, what do you say, number of nodes. Number of nodes in any block is 2 power 32 minus n. 2 power 32 minus n. So your address length is 32 bits and the prefix is n bits. So prefix will identify your network and suffix will identify the node. So the suffix say 192.168.0 say 220 point something 31 2 3 4 5 6 like that it goes. So you can identify the node, particular terminal, particular computer, if you make it much more simpler with the suffix. Okay, so your home router assigns say 192.168 what is it, 0.1, 192.168 0.2, 192.168 0.5, like that. That is the way. So the last digit is identifying the particular node, the terminal. So the first prefix, to find out the starting address, you say you will keep all the bits, all the prefix bits, and then change all the suffix bits to zeros, rightmost bit to zeros. And for obtaining the last address, you will maintain all the prefix bits and change the suffix bits to 1. So you will get the first address and last address. First address and last address. Please be aware of this because we will use this in the problem. All right. Then please you have a classless. So you don't have classes. You have the prefix length specified along with the address. So some cases it is understood. Say for instance, for 192.168, your private IPs, it is here. Usually the mask what is the prefix length, that is 12. Okay, so here in this not 12, 16, sorry. So here I have an address which is 23.14.23.14.67.92/12. So you say this is the what do you say, the prefix length, the n bits is 12. So I am writing down into converting each of these decimal values into binary. Okay, this is 23, then 14, then 67, then 92, right? Now the first address, what you do is that you will maintain all the bits up to the 12th bit. So this is 8, 16. So this totally 16. So 8, 9, 10, 11, 12. So I'll maintain all the bits up to here same, and so in this case you will maintain everything, so this bits up to here the same, so and rest are 0. So anyway it becomes 23.0.0.0, right? Right? Is there any doubt regarding right? Then who replied actually? So again the last address you will make this thing, the first bits you will keep this same and then put all these as ones. So you will get the first address and last address. So 8 bits make 255. So അടുത്തൊരു ബിറ്റ് വരുമ്പോൾ ഇത് ഇൻക്രിമെൻ്റ് ആവും, അങ്ങനെയാണ്. ബൈനറി, you just remember binary. So maximum length possible with 8 bits is 255. അപ്പോൾ അടുത്തൊരു ഇതാണെങ്കിൽ 16 ആവും, 23, 16, 0.0 അങ്ങനെ പോവും. You get it? Right? When we do a problem we'll understand. So the number of nodes in this is 2 power 20. So if you have a larger prefix length means you will have fewer nodes. If you have smaller prefix means, suppose I have the prefix length as 8, that means you are going to end up with 2 power 32 minus 8, these many nodes, right? So that is what do you say? So that is the thing. So a larger network will have smaller prefix length. Hope that idea is clear. Now it's much easier to do this thing in a computer. Say it can just find out the complement. Okay. You can use the address mask. Address mask is something where you set the leftmost n bits to 1 and the rest of the bits are set to zeros. So you can use the address mask to find out the address by and or and not operations. And or and not operations can be used. So address mask is another way to find out the first and last address. Just understand that. If whichever method you're comfortable, you can use that. This will be much more useful while doing problems. But on a PC this would be a much more easier thing. The computer can find out if it has a mask specified, you specify a mask. So the first n bits are ones and the rest are zeros. 32 minus n bits are set to zeros. Here the PC, on a PC the OS can do this thing. You can do this this operation. So number of address in the blocks means you just note the mask in decimals and just add a 1 to it. Okay, first address in any block, you'll just take any address in the block and add with the mask. And last address in any block, any address in the block or of the complement of the mask. That will be the operation, right? Take up any number and do it. Do this thing. So you'll just take the mask, just perform an AND operation with any address in the block. Okay, so why we need all these addresses means the address is used for routing purposes. So your router, we are now in network layer of the TCP/IP protocol. So network layer has this device called as router. If you recollect from the earlier slide, so router has something which is called as a forwarding table, routing table, whatever you call it as. So we are here, we are in the network layer. So it's IP, internet protocol layer. So the router is checking to which network it has to forward. To do this thing, it has to verify, it has to have some table called as a forwarding table. It will have this network address and it will know to which output line. So router is a device, you can say this is a device with say n input ports and m output ports. Some data comes in, some packet comes in through its one interface. It will have to check to which interface it has to send. So that will be known. So it will be having some estimate that this is this network. Okay, so this is the routing process. You will have a destination address. You will have to find out locate the network address. Network address means it will have to find out the first initial parts, the prefix. So later on we will see that there is some concept called as root aggregation or root summarization. So we'll see that. Okay, so basic idea is this. It just forwards to that particular network. It just checks the address and just forwards to that network. Say that is the basic idea of routing. Now we mentioned about IP address. So IP address is allocated. There is a hierarchy of body to allocate the IPs. Say there is globally it is done by ICANN. ICANN is international internet assigned numbers authority, and so Internet Corporation for Assigned Names and Numbers, that is ICANN. So these two bodies are managing this thing. This is a not-for-profit body, something like that. If you visit this address iana.org/numbers, you will get to know more of this. So, and they will allocate this to regional registries, say Africa, Asia Pacific, I think American, then we are in Asia Pacific. This is Latin America, I think so. So this regional registries will allocate to their regions. So they will allocate blocks of IPs to this regional registries, regional internet registries, and the ISPs will buy from these regional registries. Say for instance, say say Kerala Vision or Asianet, they won't directly buy from this regional registries or all such things. There will be intermediate private companies who would have purchased blocks of IPs from this intermediate registries. So nationally or regionally, globally there are registries which are reliable. So you will buy this IPs from IP blocks from this IPs regional private players, usually private players, and then ISPs will allocate to users, all those things. So big users, small users, some big users will require static IPs. IPs should not change. Whereas say small users like us will have a dynamic IP. Every time you connect, you are leased an IP, right? So there is a case of directly assigning IPs also. But anyway, this is the process. So this is a hierarchy. So this is RIPE. So this is RIPE. NCC is the European. Okay, I don't know what's abbreviation for this. So this is we are in Asia Pacific. So right. So allocation usually is done in blocks of 2. You won't allocate say 1000 IPs, rather you will allocate 1024 IPs or 2048 IPs. IPs are allocated. It will be in powers of 2 because we are dealing with binary number system, and you will you have some discretion there when you allocate blocks. So this is something to be very much followed. The first address of the block should be divisible by the number of addresses in the block. So that is one very important thing. So you will convert all those things, IP address to decimal, and you will check whether it is divisible by the number of addresses in the block, right? The total number of addresses in the block you will be able to get, isn't it? So first address minus last address, right? So that will be the number of addresses in the block, or 2 power 32 minus n, that will give the number of addresses in the block. Either of these, right? Number of addresses in the block can be obtained like that. So this should be divisible, exactly divisible by this, the number of addresses in the block, right? Now the problem is that you can have say if this registries give unique IDs to each of us, at some point we will exhaust the IP. So that is why we have this hierarchy. So this hierarchy is to ensure that there is something called as subnetting. So IPs are allocated, blocks are allocated to IPs, and sub-blocks are allocated here, which is further subdivided and allocated to small players. In fact, it is very easy to get a ISP license in India. You just, it depends on your if you don't plan for a whole India, pan-India operation, if you don't plan to cover the entire India, then you need to spend only say a regional operator, say Trivandrum district, say 10 lakh rupees guarantee, bank guarantee, and plus then you need to have the provision. You can buy IP from someone, then allocate this, you can run an ISP of your own. There is a licensing procedure. You just see how to get a license. There are other than the known players, Reliance, Jio, all those things, we have small players. A lot of small players are there. Okay, so designing subnets. So subnetting, this is some topic which we will take, which are going to take up. So designing the subnets in classless addressing. So classless addressing, you have the IP address along with the prefix length specified. So you will now just take your paper and pencil, right? So we are going to design some subnet. So you will allocate a block and you will find out the start address, end address, and suppose subnets starting address and ending address, right? I hope you have the paper and pencil ready. അല്ലേ? സമയം തീരാറായി. അതിന് മുമ്പ് നമുക്ക് തീർക്കാം. ഒരു പ്രോബ്ലം തീർക്കാം, ഒരു പ്രാക്ടീസ് എക്സസൈസും തരാം. പേപ്പറും പെൻസിലൊക്കെ എടുത്തോ? ഇവിടെ ക്ലാസ്സിലെ ആളുകൾ ഉണ്ടാന്ന് നോക്കട്ടെ. ഓർ ഐ എം ജസ്റ്റ് സ്പീക്കിംഗ് ലൈക്ക് ദാറ്റ്. 47 people. പേപ്പറും പെൻസിലൊക്കെ എടുത്തോടെ. Rixan Ladol, you have the paper and pencil with you? Yes, no, yes, right. Nisam paper pencil ഒക്കെ എടുത്തിട്ടുണ്ടല്ലോ അല്ലേ? പേപ്പർ പെൻസിലൊക്കെ എടുക്കുക. എടുത്തു. ഓക്കെ, സോ we'll just work it out. So നമ്മളുടെ ഒബ്ജക്റ്റീവ് ഇങ്ങനെയാണ്. അപ്പോൾ നമ്മൾ number of addresses that is assigned to each subnetwork. Subnetwork is subnet. Subnet is n sub. We'll call it as n sub. So and you'll see how. So n sub, this suppose you say you are assigning 256 addresses. Say 256 addresses. We'll work out a problem that should make it clear. So that is and this is n, small n sub is the prefix length of the subnet. Small n sub is the prefix length of the subnet, right? Capital N sub is the number of addresses assigned to each subnet. So you say this subnetwork has 64 nodes. You are to assign 64 addresses, and n sub will be the prefix length of that subnet. This slash വരുന്ന ഭാഗമാണ് n sub, small n sub. കേട്ടോ? I wished I could use two different notations, but this will be useful. This will be better. So this is one thing which you need to note, but we won't always check this divisibility. Rather, we'll just see. We'll start from bigger subnets. Suppose you have to allocate to say 500 addresses, then 200 addresses, like that. We'll start with 500, allocate like that. We'll see a problem. So just take note of this. Say this, there is some ISP is granted a block of addresses beginning with 14.24.74.0/24. Okay, 14.24.74.0/24. Now they have to allocate to 3 users. One requires 10 addresses, other requires 60 addresses, and other requires 120 addresses. Okay, that is the idea. So these 3 addresses, 3 blocks. ഇപ്പോൾ അലൊക്കേഷൻ എങ്ങനെയാണ്? ആരെങ്കിലും ഒന്ന് പറയണം കേട്ടോ. ഇതിൽ എത്ര അഡ്രസ്സ് അലൊക്കേറ്റ് ചെയ്യും? നമ്മൾ 10 ആയിട്ട് അലൊക്കേറ്റ് ചെയ്യും. പവേഴ്സ് ഓഫ് 2 പറ്റുള്ളൂ. അപ്പോൾ എത്ര വിടണം? 16 മതി. 16. ഇതിന് 64 കൊടുക്കുക അല്ലേ, പവർ സബ് 2ൽ 64. ഇതിനാണെങ്കിൽ 128 കൊടുക്കുക. അപ്പോൾ 128. n sub, so you will say this is n sub 1 is 128. Capital N sub 1 is 128. This is capital N sub 2 is 64 and capital N sub 3 is 16, right? So this is say this is your problem. So you start working on this. I'll just shift the slide. I'll tell you something that happened. So I worked out this problem in a text file, okay, in a Beamer PDF PPT, and I finally ended up with only the PDF file because അവസാനം സേവ് ചെയ്യാൻ ചോദിച്ചപ്പോൾ ഞാൻ വേറെ ഒരു ഫയൽ ഓപ്പൺ ചെയ്യേണ്ടായിരുന്നു. അത് ഇതിൻ്റെ പുറത്ത് ഓവർ റൈറ്റ് ചെയ്തു. I lost all the text file. So you will come across some errors there. I'll tell you what errors are there. Okay. You can see the slide. I'm just, oh yes, I've just uploaded it. സ്ലൈഡ് കാണാമല്ലോ അല്ലേ. അപ്പോൾ ഞാൻ ഈ PPT ഉണ്ടാക്കി ബീമറിൽ, ലാറ്റക്കിൽ. എന്നിട്ട് അവസാനം വേറൊരു ബ്ലാങ്ക് ഫയല് ഇതേ പേരിൽ അങ്ങ് സേവ് ചെയ്തു. I had compiled it, that's why I got saved. Anyway, whatever it is, so okay. Recording has shifted to this. So this is what your problem is. So you have to calculate the range of network and the address, subnets. So the solution, we'll discuss the solution. Your number of addresses, you will start with this thing. So the total number of addresses is 2 power 32 minus the prefix length 24, alle 256. That will be, you are going to allocate 256 addresses. Thread allocate ചെയ്താൽ മതി. അപ്പോൾ അത് 128ഉം 64ഉം 16 ഇങ്ങനെ 3 ഇതായിട്ടാണ് അലൊക്കേറ്റ് ചെയ്യേണ്ടത്. You are going to allocate it as 128, 64 and 16, right? Any doubts ഉണ്ടെങ്കിൽ പറയണം കേട്ടോ. We'll clear it. Okay. Now the first subnet you have okay, size 60 അല്ല, സൈസ് 120 ആണ് ചോദിച്ചേക്കുന്നത് അല്ലേ. 120, അതാണ് എറേഴ്സ് ഉണ്ടെന്ന് ഞാൻ പറഞ്ഞതാണ്. So size 120, the first subnet address is 120. So it has to, size is 120, so we'll allocate 128, right? So 32 minus log 2 to the so n sub to the base log 2. So you will get എങ്ങനെയാ logarithm to the base 2 കണ്ടുപിടിക്കണമെന്ന് അറിയാത്ത ആളുകൾക്ക് ഇതാ logarithm to the base 10 of the number by logarithm 2, or else on a calculator you might have log 2 directly. So 25 ആണ് അതിൻ്റെ prefix length, 25 prefix length 25 ആണ്. Is this clear, right? ക്ലിയർ അല്ലെങ്കിൽ പറയണം. വർക്കൗട്ട് ചെയ്ത് നോക്ക്, പെട്ടെന്നൊന്ന് വർക്കൗട്ട് ചെയ്ത് നോക്ക്. It will take 5 more minutes. We'll just complete this problem and just leave. Hope people are writing. എടേ അലൻ ആൻ്റണി ആണോ VSSC പോകുന്ന ആൾ, അലൻ ബേബി ആണോ VSSC പോകുന്ന ആൾ? ഇയാൾ രണ്ടുപേര് ഒരേപോലത്തെ പേരുള്ള കാരണം എനിക്ക് ആരാ ക്ലാസ്സിൽ വരണമെന്ന് എനിക്ക് കണ്ടുപിടിക്കാൻ ഒത്തിരി ബുദ്ധിമുട്ടാണ്. തിരുവനന്തപുരത്ത് നിന്ന് വരുന്ന ആളാരാണ്? അലൻ ആൻ്റണിയാണോ അലൻ ബേബിയാണോ? ഹലോ, ഇവിടെ ആരും ഇല്ലേ ക്ലാസ്സിൽ? അലൻ ആന്റണിയാണ് VSSC പോകാൻ പോകുന്ന. VSSCയിലുള്ള അലൻ ബേബിയാണ്. റൈറ്റ്. Batchmate told means correct. So Alan baby is not coming to the class. Get up. Tell I have noted. I taken note that he hasn't attended the class over the past 3 weeks or so. He doesn't come to the class. At least he could put his picture here and leave. I have no other way to verify. Rep, please tell this Alan baby. Alan Anthony joined. Alan baby doesn't come. Right. So problem ചെയ്യണ്ടല്ലോ അല്ലേ? അപ്പോൾ സ്റ്റാർട്ടിംഗ് അഡ്രസ് ഇങ്ങനെയാണ് 14 24 74 0 and the prefix length 25. So this is 8, then 16, this is 24 bits, then this is 25. So I'll maintain all these bits just like that, and then change all these things to 1. So you'll get 127. That is 0 to 127 is 128. 128. ഇതാണ് എറർ ഉണ്ടെന്ന് പറഞ്ഞ കാര്യം. എനിക്കിപ്പോൾ മോഡിഫൈ ചെയ്യാൻ വേറെ മാർഗ്ഗമില്ല. I lost the text file. The problem I'll tell you. I just absent mindedly അങ്ങ് പറ്റിപ്പോയത്. ടെക്കിന് അങ്ങനെ റിവേർട്ട് ഓപ്പറേഷൻ ഒന്നുമില്ല വേർഡിൻ്റെ പോലെ. So this is subnet 60. Size 60 we'll allocate in 64. അപ്പോൾ അടുത്ത അഡ്രസ്സ് തുടങ്ങുന്നത് ഇവിടെ വിട്ടിരിക്കുന്ന അഡ്രസ്സിൻ്റെ അടുത്ത അഡ്രസ്സാണ്. ദാറ്റ് ഈസ് ഒരു ബിറ്റ്, നെക്സ്റ്റ് ബിറ്റ്. സോ ദാറ്റ് ഈസ് 128. ദാറ്റ് ഈസ് 14. സോ ദിസ് ഐഡിയ is clear. Subnet mask length. Subnet mask length is what is it? 26. N sub, small n sub. So that is 14, 24. So and this bit is 128. ഇവിടെ വരെ 127 വന്നു. So 7 bits is 127. So next is 128. So 128. You will maintain all say 26 bits the same. That is this much is 24. That is byte and 8 bit. 8, 16, 24, 25, 26. So I'll maintain all these bits like that and then just change this thing. So 191. So അടുത്ത അഡ്രസ് റേഞ്ച് എവിടെ നിന്ന് തുടങ്ങാം? അടുത്ത അഡ്രസ് റേഞ്ച് എവിടെ നിന്ന് തുടങ്ങാം? 14, 24, 74, 192 എന്ന് തുടങ്ങും കേട്ടോ. 192 ആണ് അടുത്തത് കേട്ടോ. 192 ആണ് അടുത്തത്. someone asked something or someone came. എന്തോ ഒരു മണിയടി കേട്ടോ അവിടെ. ക്ലിങ് എന്ന് പറഞ്ഞ് മണിയടി കേട്ടോ. Okay, fine. So this is 192. 192. So 192, that is yeah. 1, 2, 4, 8, 16, 32, 64, 128. Right. So that is 192. So this is your 192. So you'll have to, the subnet mask is 28 bits. So എത്ര വരണം? The 8, 16, 24, 25, 26, 27, 28. You will have to maintain all these bits like that. So I'll just maintain like that. So the starting address we know, the ending address this is. So this is 207. So the total number of allocated address is this 208. 208 has been allocated. 0 to 207. That is ഇവിടെ കണ്ട എറർ പറ്റിയിരിക്കുന്നുണ്ട്. 2 total allocated ഇവിടെ 2. I forgot to change it. 74.0 കേട്ടോ. This is 0. I can't change. I have no other option. It's like I wrote on the board and erased it. Just it will be better to think like that. So I have still 48 addresses unused because in the block out of 256 you have 48 addresses unused. You can allocate to someone. Okay. That is each of these categories you have fewer addresses because we didn't allocate as exactly as 60. We allocated as 64. Right. So 48 addresses are still unused in this block. So this will be the address space. Hope that problem is clear. Problem clear alle? Hello, anyone wants a repeat of this? Anyone wants a repeat of this problem? No one. Hello, yes or no? എന്തെങ്കിലും ഒന്ന് പറ. Hello. No. കുഴപ്പമില്ല. Aparna Kiran, you're okay with this problem, right? Basit എന്താ അവിടെ? Yeah, you're okay with this. So മനസ്സിലായി. അപ്പോൾ അടുത്തൊരു ഇത് കൂടി ചെയ്യാം. So this is your address space. So your total block is this 256 addresses, and I have divided into 128, then 64, 16, and then 48 unused. So this is what you will draw in your exam as well. എങ്ങനെ എഴുതി വെക്കുക, അങ്ങനെ ചെയ്യാം. അറിയണം. You should know what is being allocated. So subnetting ideas concept is clear. I hope so. So we'll just do a practice exercise. Practice comments ഞാൻ അവിടെ എഴുതി വെച്ചിട്ടുണ്ട്. കാര്യം എന്ന് വെച്ചത് 34 അല്ല 40 ആണ്. ഞാൻ പിന്നെ ഇത് കറക്റ്റ് ചെയ്തത്. So this is program 40. So an ISP is granted a block with the address 234540.0/21. 0/21 40 ആണ്. 45 കഴിഞ്ഞിട്ട് 40 ആണ്. Please take note of that. 234540.0/21. ഈ കമൻ്റ് ഒക്കെ എഴുതി വെച്ചൊക്കെ ഞാൻ ഓർക്കാനാണ്. കമൻ്റ് ഉണ്ട് അവിടെ, ഞാൻ എഴുതി വെച്ചിട്ടുണ്ട്. എന്താണ് കമൻ്റ് ക്ലിക്ക് ചെയ്ത് അതങ്ങ് അപ്രോച്ച് ചെയ്തു. ഇത് ഫോർവേഡ് ആയിപ്പോൾ. So and it has to allocate say 500 addresses to some 2 people, 500 addresses each. Then other one guy requires 250 addresses, and smaller 2 people require 50 addresses. Okay, so 500 etra allocate cheyum? How many addresses will you allocate for 500 in powers of 2 people? When 5 and 2, right? 5 and 2. Who responded? Sanjana, right? Fine. Then 250 ആവുമ്പോൾ 256 allocate ചെയ്യാം. Okay. And 56 ആവുമ്പോൾ എത്ര? 50 ആവുമ്പോൾ എത്ര കൊടുക്കണം? 50? 64, right? 64. So you are going to do this problem, and I have the solution worked out here. So just do this as a practice exercise. That is for the day. So you just do this as a practice exercise so that you are clear about the concepts. ഇതിനകത്ത് after you do this, so tomorrow we take up this solution. അത് കഴിഞ്ഞിട്ട് ബാക്കിയുള്ള റിമൈനിങ് ടോപ്പിക്സ് കൂടി തീർക്കാം. സോ ഇത് ചെയ്തിരിക്കുന്നതല്ല. ഇതുപോലത്തെ ന്യൂമറിക്കൽസ് ചിലപ്പോൾ എക്സാമിന് ഉണ്ടാവും, ചെറിയ ന്യൂമറിക്കൽസ്. ഇതിനിപ്പോൾ ഇങ്ങനെ അലൊക്കേറ്റ് ചെയ്ത് പോകാം. യു ആർ ഗോയിങ് ടു അലൊക്കേറ്റ് 2048 addresses. All those things this will be a sort of questions that could come up. Okay.